Hi, everyone. Thanks a lot for coming. I'm Nikhil from Google, and we are going to present a deep dive on the projects that SIG Multicluster is working on. So yesterday, we gave a brief overview of all the projects. Today, we are going to go deeper, and feel free to ask questions. We have some great demos lined up. So the way we've structured is we have 3 demos today. First, I'll start with demoing kubemci, which is our tool for multi-cluster ingress. Then Lindsay from Red Hat would demo Federation V2 prototype. And then Irfan from Huawei will present Federation V2 cross-cluster service discovery. And as we present these demos, feel free to ask questions about any of these as you have them. And in the end, we'll have time for more broader Q&A. So I'll start with kubemci. And this is like a high-level overview of what kubemci does. The use case that it solves is you have the same app deployed in multiple clusters globally across different continents, regions, and you want a single load balancer across all of them. You get a single IP address that you give to all of your customers, and automatically users from Asia are routed to Asia cluster, and users from US are routed to US cluster. So this ensures that there's least latency. And then another advantage you get is even if one cluster goes down or the app in that cluster goes down, the load balancer automatically fails over to other clusters. So this helps you build highly available apps. Your customers get just that single IP, and load balancer takes care of ensuring that it routes the traffic correctly. So this is the use case that kubemci solves. And the way it solves is it's a command line tool that you can install on your machine, give it your Ingress spec, which is the standard Kubernetes ingress.yaml file, and your kubeconfig, which has list of clusters. So the great thing about kubemci is that you can use your existing Kubernetes concepts to configure. So right now it works with Google Cloud Load Balancer, which supports this use case. You can directly you can go outside Kubernetes and directly configure Google Cloud Load Balancer to do the same thing. But kubemci enables you to use your existing Kubernetes concepts that you're familiar with to configure Google Cloud Load Balancer. You take your Kubernetes Ingress spec and kubeconfig, things that you're already using with Kubernetes. So you run create command, it configures Google Cloud Load Balancer and gives you a single IP address. So I'll show you a demo of how this works. So for this demo, what I've done is I have a few clusters set up. I have 2 clusters, one in Europe and one in Asia. I have this kubeconfig YAML that has 2 contexts, one for both of those clusters, so cluster EU and cluster Asia. I've already deployed the same app across both of them, so I'm using a sample zone printer app. What it does is it prints the location from which the request was handled. So if you hit that IP address, go to one cluster, it'll print location of that cluster, and if it goes to the other cluster, it prints the location of that other cluster. So you get to see this routing, like from where was my request handled, which cluster handled my request. So for creating the ingress, I'll use kubemci, and I'll show the ingress spec that I'm using. So this is the command that I use for running kubemci create. I give it a name. So here I give it a name, new kubemci zone printer. I give it ingress.yaml and my kubeconfig.yaml, which has those 2 clusters. So just standard Kubernetes concepts. When you run this command, what it does is it then goes in and configures GCLB. That takes some time. It creates ingresses in the clusters. So configuring GCLB is like configuring 7 resources. You have to configure health check, backend services, firewall rule, forwarding rule, all of those stuff. So it'll do all of that, and then hopefully in the end say success if the demo works. So it supports you can create HTTPS load balancer. In this case, I'm just creating a standard HTTP load balancer. Woohoo, finally it said success, so it worked. So you can list your existing ingresses using kubemci list command. That would list all the multi-cluster ingresses that you've created. And so here, if you see file list, I see 2 multi-cluster ingresses, one that I just created, and I have an existing ingress which I'm actually going to use for this demo. It takes some time to configure GCLB and for all those routes to be propagated. So I'll use the existing MCI that I have, which is the kubemci zone printer. kubemci also has a get status command. You want more information about one particular MCI you created. It prints the IP address, the clusters that it's spread to. So now we have this IP address 35.201.1082. I'll access this IP address from here. And since I have 2 clusters, one in Europe and Asia, I should hopefully hit Europe. So here I see that like this is the output that it says my cluster is running in Belgium right now, so my request was handled to Belgium. If I hit the same IP address from Asia, it would be served from an Asia cluster. So I have this service that I'm using called GeoPeeker, which I use to hit that same IP address from all through the world. And let's see if I access that IP address. I'm using a free version of this service, so it sometimes takes long and times out, but hopefully you'll be able to see. So it's hitting the same IP address from different parts of the world. You see it hits that IP address from Ireland, Virginia, Brazil, and those requests are handled by Europe cluster. And if you hit it from Australia, California, those requests are handled by Asia cluster. So GCLB is automatically sending traffic to the right clusters to ensure least latency. We have also a cool demo at the GCP booth where you can get more information and ask more questions as well. We don't have, in this demo, I don't have like a US cluster, so it goes to the closest. I only have 2 clusters in Europe and Asia. Yeah. Europe, yeah. Yeah. Yeah, that's it for the demo I have. If there are any questions, or we can take more questions at the end as well. Okay, I'll invite Lindsay for the next demo. Thank you.
Oh, wait. I think I have to.
You need one?
That works. Oops. Okay. So I'm going to be demoing the Federation V2 prototype. First, I'm Lindsay Tulloch. I'm a software engineering intern at Red Hat in Toronto. And I've been working on multi-cluster since last year around this time. So if you've been following SIG multi-cluster at all over the past year, you will have noticed a lot of discussion around the future of Federation or now multi-cluster and what are expected or what the best trajectory would be into the future. So we did take Federation out of Kubernetes and broke it down and started developing a new direction. And so this is kind of what I'm going to be prototyping or what I'm going to be demoing. And the core tenets of this Federation V2 are modularization and customization. So you can, the parts are more broken down and you can customize and use only the parts that you need to satisfy your particular use case. So the functional areas of Federation V2 are member clusters, templates, overrides, placement directives, propagation status, and scheduling. And I'm going to talk specifically about the template, overrides, and placement directives. And then you'll be able to see them in action. So this is a diagram that is on the Federation V2 Git repo that you can also look at. There's a bit more of an explanation there. But the replica set template, so this is specifically about a replica set. So the template is kind of like the default behavior that you want to be spread across any cluster that is federated to, or that is part of the federation. The override allows you to make some exceptions for particular clusters. So if you want your default behavior to be, for example, three replicas in each of your clusters, then you can say, but in this particular cluster, in the US East cluster or whatever, I want 5 replicas or 10 replicas or whatever. And then when you put that in the override, it will put that specific configuration in the cluster that you specified. So then the placement, which is down here, that's where you say which you specify which clusters are actually part of the federation. I think that's mostly the important things to explain. Just before I do the demo, I'm just going to make a little point about the specs that I'm using. So I did set up the clusters in advance because it takes quite a while to set it up, about 10 minutes, so I didn't want to subject you to that. So I'm using Minikube for this demo. The version is 25.2 so that I could use the profiles. So I have a cluster in US East and US West. And I'm using kube control version 1.10, Kubernetes version 1.9.4, the cluster registry, CR init tool, and API server builder, which actually brings up the federation. So you can see this is some of the script that is output when you use the API server builder, but you can just ignore that for now. And one second. Okay. Okay, so this is showing the US East and US West. Can everyone see that? No? Okay, sorry. Better? Okay. Okay, so you can see the US East cluster and all the specs, and the US West cluster. They're both running. They both have the federated or the Federation API version, and so these are the configuration files that I'm going to be deploying into the Federation. I'm going to specifically show you the Replica Set Template. So this is, as I said, the default behavior. There's 3 replicas that are going to be created in each cluster that's joined to the Federation. And the image is Nginx. That's just an example. This is the placement YAML. So the US West and US East clusters are both joined to the Federation, and that's where we're going to be deploying the replica set to. And the overrides. So for the US East cluster, I want 5 replicas instead of 3. And that will be represented. Okay, so now I'm creating all the config files. Just takes a second to go through. There's also, like, you'll notice making config maps, namespaces, and what else is in there? Secrets. So the override template is optional. You don't have to have overrides. If you want the same exact configuration across all clusters, there's no need to create an override. And that, yeah, just a note for you in case you were wondering. So you can see that the US West and US East cluster are, the namespace is active, config maps are active in both. You'll notice in the US East cluster, there's no test secret. That's because in the YAMLs I had an override, which I didn't show you, but I can show you after if you want to see it. And then the replica sets, as you can see, is just as we specified. The test replica set in the US West has the default behavior of 3 replicas, and the US East cluster has 5. So now I'm going to take the US East cluster completely out of the Federation. And it just takes a minute to reflect that. Hopefully. Okay, so, it looks like there was an error. Okay, so as you can see, the test replica set is still existing in the US West cluster as a default behavior, and the US East cluster now has no resources, which is what I had wanted to happen. And I think it aired out because there's no namespace in US East, but it was trying to find it. So 1 second. So what I wanted to do was this. Okay, so now I'm going to add the US East cluster back. And it takes a couple seconds to actually reflect that as well. Oops. Thanks. Yeah, there's some, I'll just, 1 second, again. This is annoying. Okay. So as you can see, we're still using bash scripts to print out both clusters. But it's not the end of the world. We can do this. Okay, so we're back. So the US East cluster, again, has 5 replica sets as we had originally specified, and the US West cluster has 3. And I'm not going to show you all the other resources because that's a lot of for loops that I don't want to type out, but you get the idea. So does anybody have any questions? Yes, I will try my best.
Rolling out like a new, let's say you've got a new deployment, and in your traditional Kubernetes cluster, you roll out deployment, and maybe you put in an incorrect container version of something, and obviously your pod deployment halts. Now, if you have, let's say, 100 federated clusters, have you got an idea that, like, you do a canary deployment, it starts on one, and it goes, oh, I didn't work on this one, so we're not going to try it, or would it roll out everywhere, and then everything's broken, or in a stale state?
Okay, sure.
Yeah, that's something we're busy working on at the moment. Yeah, sure. So the question was, if you have something like a federated deployment across 100 clusters was the example, and you screw up your deployment, you put the wrong image name or something in, does that screw up all 100 of your clusters, or is there some way of making sure that that doesn't cause such a catastrophe? And the short answer is, just like in a Kubernetes cluster, if you roll out a deployment, it does essentially a canary, so it does it to a small number of nodes, and if those nodes don't become healthy, then it doesn't proceed with the additional nodes. Incremental rollouts across multiple clusters are usually done in conceptually a similar way, but usually in a different way, which is that you typically upgrade one cluster, say, to 5% of the nodes on the new version, and then you make sure that those are healthy, and then assuming that they are, you progress further on that cluster. You leave that cluster to be healthy for a while, and then you proceed to the additional clusters. And so that level of configuration, like exactly what that strategy is, you cannot express in a Kubernetes deployment at the moment. And so part of V2 is to say, instead of being wed to the Kubernetes spec of exactly what a deployment looks like, we now actually have something which is a federated deployment. And it has configuration specific to how we would like the rollout to occur across the clusters. I don't think that's implemented yet, but it will be in the next, Irfan can tell us an answer to that, I think in the next month or two.
Are there any other questions? Yes.
The question is, in your demo, you configured each cluster manually. So you configured for your deployment in which cluster it should work. Is there option just to roll out the deployment to all clusters?
I don't think that exists at the moment, right? Okay.
So the intention of the demo was to show some of the lower level building blocks. So in those particular building blocks, you specify, or someone generates a config file that specifies precisely which clusters you want the whatever that thing is that you want to go into. But a quite common requirement is to say, I just want my replica set in 2 clusters, or 1 cluster in Europe and 1 cluster in Asia. And the reason why you don't want to necessarily specify named clusters is that sometimes that named cluster goes away. So it gets turned down, or it goes through an upgrade, or it gets, in some way unavailable. And you want some active management in some cases to say, well, oh, okay, I've only got it in 1 cluster now because the second cluster went away. So the idea is to have, and this goes back to the comments Lindsay made earlier about having pluggable pieces that can be composed together to perform different things. So a controller on top of that would actually generate that config that named the clusters. And that controller above it would know, oh, I want a replica of this thing in each cluster. These are the available clusters. It will pick 1 or 2 and generate that config. And if one of those goes away through active monitoring, it'll know that that's gone away and regenerate a new config file with different clusters in it. Which is not quite an answer to your question, but it does actually turn out to solve the, if you want them in all clusters, if a new cluster joins the Federation, the controller will see, oh, there's a cluster without it. The requirement was that it be in all clusters, so it'll push it out to the new cluster as well.
I just wanted to say that the configuration files that I did have, I also had config maps and secrets and whatever. I could have just had replica sets and it would have worked perfectly fine. So that's another thing that just to keep in mind.
Hi, I'm Irfan. I'm associated with Multicluster, as you might already have guessed. I work with Huawei. So today's deep dive, our intention was to try to demo the stuff that the Multicluster has been working around in last couple of months or maybe more. And the largest effort right now has been put into this Federation V2 project that we are calling Federation V2. It's sort of an upgrade from what we had Federation, but the concepts remain sort of similar. It's a federation of clusters. And I think Nikhil already covered that in the introduction of the SIG yesterday, but people who might not have been there, I'll just repeat that what we are doing as part of Federation V2 is trying to put up a set of building blocks. So Federation V1 was sort of reusing K8s APIs. It was just reusing the same API and trying to present the same kind of behavior to the user. In V2, what we have done is we have tried to wrap around that API in a federated API. So replica set becomes a federated replica set, and there are 3 basic blocks that we call. The placement is one of them. The template is what is the wrapper, and the overrides. So using that, and that is sort of now complete for us. Like what Lindsay showed is exactly those 3 types. Using those 3 types, you can control the behavior, and you can have your own type or your own API defined in the same control plane. And using these 3 types, you can have whatever behavior as you want. Like somebody asked that if you want it in some cluster, or if you want some cluster joined relatively later, or it was about the canary upgrades also. So that's the whole intention of this work group as of now. What I am going to showcase is we recently completed the services discovery part of it also. So this is sort of a high-level feature. So a high-level feature would mean that it is actually using the basic APIs. So there are 3 base APIs for services, which are the service template, the service placement, and service override. And we have put one more. And that name of that API right now is only for this demo because it's not concluded in the community. And this is done only for this particular demo. And using that, what we are doing is that we are getting the details of the service endpoints from each of the clusters and programming that detail into some common DNS server. It could be, we are using Core DNS right now, locally running on my laptop. It could be any of the other DNS servers also. So let's jump on to the demo. Yeah, typing with one hand is a little, okay. So what this does is, basically, I'll just show you the 4 YAMLs. So the first one is I'm creating a replica set. The second one, what I'll do is, I'll create, so the replica set could have, yep. Oh, sure. That's fine? Yep. Okay, so this is a template which actually specifies the details of the replica set. So what it is doing is it is using the K8s replica set as template, just like the replica set uses pod as template. Then the placement. I think these 3 features Lindsay already showed. So this is the service placement. We are not using overrides here. So I am using 2 objects for replica sets and 2 objects for services. So we have a service override and service placement. And this is the new API that we have put in only for this demo. The name is currently what we have used is Multicluster DNS. So this is the controller which is doing the high-level work. It is basically getting all the details about the endpoints from each of the clusters and programming it in the core DNS. So these are created, and it takes a little while for the pods to come up. Yep, it's creating. Okay, so this basically would have created pods in both the clusters. Okay, so these are the pods for the replica sets, and once these endpoints are ready, we should be able, so this is the naming scheme which we use for Federation. It is, the naming scheme is the service name, default is the namespace. Then Galactic is the name of the federation that we use. And some portion of this work is being done by the kubedns in K8s. So if a request hits one of these endpoints in kubedns with this kind of naming scheme, it knows where to send it. So it will also need to know about the DNS server, which is programmed for this particular federation. So we see that there are two endpoints basically returned by dig. And there are different naming schemes. Just like in local service discovery, you can have a shorter version, and then you can have zone, or you can have the region and all that stuff. Here also, when I did start the cluster, I did specify 2 zones and regions. One was in EU, as specified in this naming, and one was in US. So the discovery, while trying to figure out where this particular service is, it will return you the specific endpoint. So this one gave me the specific A record for that particular cluster. If I do it for US, it will give me the specific A record for that particular cluster. So in this case, the A record returned the IP 230. In this case, it returned IP 241. It is quite similar to what multi-cluster Ingress is doing. So it basically also knows if the pod exists in a local cluster, then it will route the traffic or it will return the DNS-based query will return the local endpoint. And if it is not existent, then it will return the remote endpoint or some other cluster's endpoint. So this is, we just do curl. So this is to showcase that which cluster it is coming from. It's a round robin scheme, so it can just return any of the pods. We had 4 pods, so there were 4 endpoints. So I'll just see. I mean, but it might return the same one also in the next query. So this time it returned a different cluster and a different endpoint. Yep. So what I'll do after this is I'll update just like Lindsay did. We actually created all this in 2 different clusters. So this time I'm removing the replica sets or the endpoints from one of the clusters by specifying only one cluster for the placement. So let's just wait for the pods to be removed. They're terminating. Not sure why does it take so much time in Minikube to remove for this particular version. I'm facing this problem. Okay, gone. So now if I do, I'll always, if I try to get those endpoints, I'll always get the endpoints which is now remaining. One of them is gone, even if I do different schemes and all. So in this case, there were routes, there were CNAMEs discovered, and eventually the A record is for that particular same endpoint. Yep, this is the local one. And the curl is to showcase that the query is actually returned from one particular cluster only, not 2, because the second one has, the parts from the second one has gone. So it's always giving me endpoints from cluster C1. Okay, so this was about just showcasing the services. If you have questions about this, I can take them now. Or any other questions about multi-cluster, we all are here right now. We can answer more. Yep.
So after you have cross-cluster discovery, I guess the next step, if I think of edge computing scenarios, is to have invocations across clusters. And I saw the IP addresses they were giving out were local IP addresses. So is your group working also on routing this request?
So what I did not include as part of this demo is what the gentleman exactly told about. That is, I could have also shown that if a local pod is not present, then it will actually return me the IP or the actual A record from a remote server. That was part of one of the digs, but I haven't done it as part of the curl. In the dig, I can show that again to you. So what you are talking about is the application access. So for that, Federation per se is not working towards that, or it doesn't consider that as in the scope of Federation as of now. So application access, a global load balancer kind of a thing probably needs to be configured separately. And I think some of the answer is for that is in the multi-cluster ingress, which Nikhil mentioned.
Hi. What happens if somebody edits the local, so for example, the number of replicas on one of the replica sets in one of the cluster? How can we restore the state that we intended initially?
Yeah, so this is because we have two points of exposure for the user. So there could be a local user also, or there could be a federation user, both of them. But our intention always has been that one of them you have to give higher privilege. You have to choose one. So currently what we do is federation overrides if any local changes are happening. So whatever changes or whatever is put up in federation as the spec, if there is a change in local cluster, it will just update it. That also enables us to adopt the existing workloads in local clusters. So for example, if you already have a replica set running in a local cluster and you just create a similar replica set specifying some replicas in federation and the replicas are same, it'll just adopt the same. It won't create a new one. So the question is, when will this happen? The sync that loop runs every couple of seconds, so it's like a matter of seconds, which is configurable.
Hi, my question may be related to the another project. It's a cluster registry. In federations, looks like you provide abstractions of loosely coupled, tightly coupled clusters. It's like abstraction of one cluster. Sometimes I am like an administrator would like to manage from the same point different loosely coupled clusters with different pods, but would like to configure the same RBAX rules or whatever. Do you plan to extend the cluster registry for this couple of capabilities? Because currently it's only add cluster, remove cluster, list clusters.
Yeah, so cluster registry right now has only the cluster list, but it's an API server and you can install CRDs in it. You can aggregate it with the Kubernetes API server as well. So then you get these other resources like RBAC, namespaces as well. And you can run controllers that watch cluster registry as well. So then if you want something like sync RBAC, so you run a controller that's watching cluster registry, which watches RBAC rules and list of clusters and then syncs them to clusters. I mean, you can run controllers with cluster registry to do more fancy stuff.
So for federated placements, is it currently possible or will it later be possible to basically specify that you want some federated resource to run on, like, say, only one cluster, but you don't care which specific cluster it would be? So for example, if you have your federation of clusters is just like 3 clusters which represent a region for you, for whatever cloud provider, and you want to say, my service needs to run in this region, but I don't want to do, like, care about the overhead of specifying which exact cluster.
Pardon? It's okay. You're done, right? Oh, Nick Young's, right. Okay. So the question is that if using these 3 constructs, I mean, what I understand it is that using these 3 basic APIs, is there a way possible to specify different intents? For example, I want to enforce a policy, or I want to specify an intent that my workload should go only in one cluster, or that kind of stuff. This is the whole crux of whatever way we have tried to architecture this separation of APIs. So what we say is that these 3 basic ones are the ones that we use to that can be used to program different behaviors. So there are 2 additional APIs that we plan to implement. In fact, we are implementing them right now, which are something to do with a policy overload. So one is called placement, which is, we call it federated placement. The other one could be considered as a user policy. Okay, so that will answer the exact question that you asked. And apart from that, it also enables to define your own APIs and implement controllers for them, which can depict different behaviors as needed by the different implementers.
My follow-up question for that would be: so, are you going to make a get started kit for a federated controller available?
The intention is to give a reference for majority of the use cases that we think are useful, and that includes some API types, and many of them were sort of already included in Federation v1, maybe not exactly the same behavior, a little different behavior or extension of the behavior, but most of it we intend to put as a reference controller in open source.
Question. This is, sorry if I miss it, this is intended to be, the DNS resolution is intended to be public-facing resolution, or is it to be intended to be internal only? The DNS resolution.
So the question is, I think what I understand is you're talking about the federation itself. The federation should be user-facing, or it should be internal. Yeah, I was doing it from the local system, so it was actually external to the cluster, but the same thing could be done from inside the cluster also. That's what you're asking?
Yes, my concern is what about DNS caching when you don't control the local DNS?
All the DNS concepts do apply over here. So that is what you mentioned about DNS caching. That actually is a problem. So we say that smart clients should actually be using this, right? So if there is a dumb client which just gets one endpoint and always uses the same endpoint to do the discovery, and one of the pods goes down, endpoints goes down, then the client thinks that it has gone down, right? So the client should be smart to understand this behavior.
It is intended to be like not a browser, for example.
Yep, yep.
Other questions? Because we are over time.
Oh, okay, yeah, please.
Yeah, we are around, so you can ask those questions.
You're welcome to approach the stand.